Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on the Space Nuts podcast. My name is Andrew Dunkley, your host, and with me as always, Professor Fred Watson. Hello, Fred.
Hi, Andrew. How are you doing?
I am well. What about you?
I'm very well too, thank you. I'm slightly cold, but I'm well.
Yeah, it's all relative. I mean, I've been complaining bitterly about the cold, but we don't get the cold that they get in the Northern Hemisphere.
No, we don't. That's
across
right.
America, Canada and Europe. So I'm not going to whinge too much because they'll think we're sooks. But it is pretty darn cold here at the moment. And they had snow in Queensland for only the third time in 35 years this week, which is... That's how cold it is. But, better them than us. Now, coming up today of Space Nuts, we're going to look at some newborn planets that have been discovered. They're being described as baby planets or something to that effect. And we're going to knock over a couple of questions that have come in. One from Tyler Lucan, who is asking about whether or not the technology exists or will exist one day for the creation of a space elevator. We've talked about it before, but it is a fascinating concept and one that would actually revolutionise certain forms of transport. And we are going to also answer a question from a Queenslander, David Baited, and commiserations, David, in anticipation of your team's heavy loss tonight. And, I'm happy to stand corrected because I'm so used to being a loser from New South Wales. But he asks, could Earth have ever had rings? That is a great question, particularly from a Queenslander. So we'll get onto that a little later. But firstly, Fred, they're describing these as exoplanet baby pictures. So what have they found?
This is... information or a discovery, I guess is the right word, that's come from basically the European Southern Observatory, which has telescopes at a place called Cerro Paranal in northern Chile. They operate 4 very large telescopes, which together are called the VLT, the Very Large Telescope, because they can actually be combined to be used together, but normally they're used singly. Each one has an 8.2 meter diameter mirror. So I know because we monitor this kind of thing. Of course, Australia is now a strategic partner of the European Southern Observatory, so we get to be very heavily involved with the instrumentation and things of that sort. And I happen to know that the instrument that has been used for these discoveries is the most popular instrument on the whole VLT suite. It's a thing called MUSE, which is the Multi-Unit Spectroscopic Explorer. And what it lets you do is look at many objects in an image in great detail, breaking it up into their spectroscopic rainbow colors and getting that barcode of information. So Muse is a fantastic instrument. It's very heavily oversubscribed. Everybody wants to use it. And this particular team, who come from, they're based in the Netherlands, but there's quite a big group. They've clearly been successful in winning time on Muse, on the VLT, and have made this fantastic discovery of a system of two newly forming planets in orbit around a star with a totally unmemorable name of PDS 70. So PDS 70 has what's called a protoplanetary disk around it. So that's been known already. That's been measured before. But in observing that disk, which I think came from observations with the ALMA telescope, the Atacama Large Millimeter Array. So you find a disk, but you look for gaps in the disk. And it's in the gaps where the newborn planets are, as you might expect, because the disk is providing the raw material that the planets are made of. And sure enough, PDS 70 has now been shown to have two newborn planets in a gap in its protoplanetary disk. They're still, these are observations that are right at the edge of possibility. One of the problems when you're directly observing planets around a star is that they're always much, much fainter than the star itself. So you've got to use a technique that blots out the light of the star, but doesn't blot out more of it than you need, because otherwise you blot out the planets as well. So that's what's happened. It's called an occulting disk that is put over the image of the star, and that hides the star itself. And then you use what's called adaptive optics to basically compensate for the twinkling of stars, the turbulence in our own atmosphere. And what has been revealed are these two little blobs, which are now thought to be the two planets of PDS 70. One is about, it's something like, if I remember right, it's about 3 billion kilometers from the parent star, and the other's about twice as far.
Okay.
6 billion kilometers, which is kind of, it's more or less the distance of New Horizons from the sun is 6 billion kilometers. So when New Horizons flew by Ultima Thule,
it's really
a little
getting
while
out there, isn't it? Sounds
I think it's 6.5.
Similar to a Kuiper belt situation, isn't it?
Yes, that's right. So this protoplanetary disk is much bigger than the solar system, and has these two objects. So the nearer one is about the distance from Uranus to the sun, and that is thought to be an object which is between 4 and 17 times the mass of Jupiter. So this is very difficult to estimate, but it's a big object. And actually, if it goes over 13 times the mass of Jupiter, then it's classified as a star, a thing called a brown dwarf star, because it's 13 Jupiter masses is the lower limit for one of those. So it's almost certainly a planet, smaller than that, but clearly a big object, and it has to be, because you're looking out to a distance of, if I remember rightly, it's about 370 light years away. I mean, you're looking a long way through the disk of our galaxy. And the other one, which rejoices in the name of PDS 70c, because B is the inner planet, C is the outer planet, that's probably a little bit more uncertain. They're suggesting that it might have a mass of 1 to 10 times the mass of Jupiter. So they're still gas giants, effectively. They're large planets, but it's astonishing that we can see them directly from 370 light years away.
Yeah, and they sound enormous. I mean, they're just... you look at Jupiter and think, wow, but if these things are so much bigger, it is quite astonishing.
Yes, that's right. It's... I mean, I guess what this is saying is that the way the technology is at the moment, you're only going to discover the big things. Yeah. And, so you might well end up with the technology we have now, just picking off the totally delinquent ones that are at the extreme size of the planetary mass range. So as perhaps time goes on, and certainly when we get into the era of ELTs, the extremely large telescopes, which are the next thing on the horizon, they will be able to image planets much more easily than we can now. And in a sense, this Muse observation is almost testing the kind of technology that we'll use on extremely large telescopes. The biggest one will be the European one. It will be not very far, actually, from Cerro Paranal at a place called Cerro Armazones in northern Chile. That will have a mirror 39 meters in diameter. It will be the biggest optical telescope in the world by a long way, and will be run by the European Southern Observatory, like the VLT is.
And I suppose when those telescopes start to come online, we're probably going to make discoveries that are very, very difficult to make at the moment, such as the situation with PDS-70. We've found two gas giants, but there's a possibility, maybe a probability, that there are rocky planets closer to that star that we can't see at the moment.
Yeah, absolutely. That's right. So, the sky's the limit when it comes to new telescopes. When you plan a new telescope, you always put together what's called a science case. You try and think of the kind of science that you might do with it. And that's usually involves a lot of hard work by a lot of very clever people to say how you would study things with this big telescope. But the most exciting thing about big telescopes is the stuff that you didn't expect to discover, because they always produce results that come completely out of the blue and surprise everybody. So really looking forward to the EELT, the European Extremely Large Telescope.
Yeah, it sort of gives you a feeling that we're just on the cusp of the next generation of discovery. It just has that feeling about it. All right, we'll keep an eye on things and can't wait for those new telescopes to go online. You're listening to Space Nuts. Andrew Dunkley here with, of course, Fred Watson.
Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're going to go to a question early this week because we were both kind of entranced by this one, and it's something we've talked about before. And thank you to Tyler Lucan, who has sent us this question from the wonderful nation of Canada. Actually, he's said, you are my favourite podcast, and he said, not spelt wrong, Canadians put a U in it. Yeah, so do we in Australia. we do put a U in favourite. So it didn't look wrong to me at all. Anyway, he said, I've been listening since the beginning and I just love seeing the continued development of the podcast since your start. I really like the inclusion of listener questions, which is why I am now writing. Now, he says, we've all heard of the great science fiction idea of space elevators, and although there would be great benefits for one to bring payloads from Earth's surface to
LEO is low Earth orbit.
Low Earth orbit, I knew that. Current material science isn't advanced enough to make a substance or compound that could stretch up into the orbit, into orbit and not succumb to its own weight and snap or collapse. So if we can't yet do it on Earth, has any serious consideration or investigation been made to see if it's practical to make a space elevator on the moon? Would this not be great and beneficial for upcoming plans to restart lunar surface explorations by womankind and mankind? Again, I love the show and your passion to deliver such knowledge and news. Cheers from the humble village of Bowser, British Columbia. Thanks, Tyler. Good question. Space elevation.
Yeah, and it's certainly was proposed originally for science fiction. The idea being that you connect a spacecraft in a geostationary orbit with the ground, because a geostationary orbit, by definition, stays above the same point on the equator. And there has been a lot of serious study of this, and in fact books have been written about space elevators and what we need to do to make them. So clearly what you've got to do is stretch something upwards from the equator 36,000 kilometers and connect with the spacecraft, the geostationary satellite, and then you build a lift and send things up and down on it. You do have a few other little technical issues, including the fact that I think you've got to build a sort of compensating version out the other way from the spacecraft to make all the dynamics work. But the real killer for the space elevator, certainly as far as the Earth is concerned, isn't so much the technology. That might be a killer, because exactly as Tyler says, the stresses and strains on the material that you would need are probably beyond current material science. So we don't have the carbon fibers and things, or whatever is needed, beryllium fibers, who knows what it might be that you need to build one of these. We don't have that yet, so we can't do it. But the real killer for the space elevator was something that was pointed out to me by a fairly learned person one day when I was lucky enough to have dinner with him. That was Buzz Aldrin.
Oh,
You've heard of Buzz Aldrin?
I've met Buzz Aldrin.
Yeah,
yes.
Yeah. So we were talking about the space elevator, and he said it's not going to work. And his point was very well made. And it's that our current situation in space, of all the space debris that's up there, actually prevents it from happening.
Yeah.
And that's because you've got to build it up from the equator, or else it doesn't work at all. And every piece of orbiting space junk crosses the equator twice in its orbit. Once going northwards, once going southwards. So there is always going to be stuff which could threaten the space elevator. So unless you can sort of armor plate it for that whole region from low Earth orbit upwards, you're always going to be at risk of a collision. And that could be from a tiny piece of space debris that might just hit a critical component, or the elevator on its way up, or it might be from something much bigger. So he was very, very down about the idea of the space elevator, and Buzz is not known for being negative about things, because he's one of the great champions of space travel, as you'd expect. But yeah, the space elevator, he said, as far as the Earth's concerned, is a non-starter, and it was a very interesting thing to point out, which I have to say, in my ignorance, I hadn't really thought of before. Now,
funnily enough, that was my first thought. When we started talking about this, I thought, well, the first problem they're going to have is not getting hit by something. That was my first thought.
Well, you're just such a far-sighted thinker, Andrew. That's why I talk to you
Probably
every
just dumb luck, really, but it is, like he says, it's the biggest problem. We've talked about the junk in space and the efforts to try and get rid of it, but some of it's so tiny that they'll never be able to catch it.
That's right. Eventually will spiral back to Earth and burn up in the atmosphere. It'll be a little shooting star, but of course this now informs the question that Tyler has asked about why don't we do it on the moon? And I haven't studied the phenomenon of what you might call selenostationary orbits. There must be studies of that. Seleno is the prefix to do with the moon. Selenography is the mapping of the moon. So selenostationary orbits, I don't know what height they would be above the moon's surface, but I suspect it is actually a possibility that perhaps you could use technology that is at least on the horizon today to build a space elevator into lunar orbit. My question would be, what is what's the killer benefit of that? Because it would only be, I guess, really physically, or let me put it this way, commercially profitable. Because a lot of this is going to be determined by commercial considerations. It would only be commercially profitable if you were mining raw materials from the moon in a big way. So big that you would save the money of launch costs by actually building the elevator. I suspect it would always be more, given the moon's lower gravity than the Earth. I suspect it would always be more economical to fly them up there using more conventional technology. But it is a really interesting idea, and once again, Tyler, something I hadn't thought of before: the idea of a space elevator on the moon. It would be worth checking up, see if anybody else has come up with that idea.
I can see many reasons why it would be easier to do on the moon. Certainly, much less space junk to deal with. But given the reasoning behind our current plans to go back there, it's probably not a feasible way of getting up and down. So, maybe in time when they are perhaps harvesting on the moon, if that ever happens, they may well find that a space elevator becomes economically viable. So,
there could be. Sorry, just to cut in there, because I meant to say this earlier but forgot. There could be a real problem with the lunar space elevator as well, though, and that is the gravitational perturbation of the Earth, because on the Earth you do have the gravitational effect of the moon to consider in building your space elevator, and that's going to put wiggles into it. But that problem is much greater the other way around. If you try and build a space elevator on the moon, you've got this huge gravitating body not very far away that's effectively disturbing the elevator. And you might find that you essentially set up oscillations or something in the elevator which would simply be unsustainable. So there might be physical reasons why you couldn't actually do it, as well as wondering whether it's economically worthwhile.
Of course, the other thing is we just wait until the moon drifts far enough away for that not to be a problem.
Yeah, that's absolutely right.
There you go. So there's a solution to everything.
Actually, there's an even better solution. Here, wait for this one, Andrew, because when the moon has gone that far away, it will be about 500,000 kilometres away. This is the sort of stable end result of the solar system. And the same side of Earth will always face the same side of the moon. So you can actually just stretch a long elevator between them, because they're always going to be facing each other.
That'd be just pretty cool.
Send people that way, yeah. 380,000 kilometre, a 500,000 kilometre long space elevator. Remember where you heard it first.
Yes, indeed. And I think it was Kim Stanley Robinson in his Mars series that actually had a space elevator going between Earth and Mars, but I don't quite know how that worked. But
no, that's a tricky one.
Yeah, very tricky one. But he did it. I mean, it's science fiction. You can do whatever you like. Yes. Thank you, Tyler, for such a wonderful and thought-provoking question. You're listening to Space Nuts, Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine. Space Nuts.
Now, just before we get to our next question, reminding you that we have a Patreon account, and thank you to everybody who's signed up to subscribe. 16 people now subscribing to Space Nuts via patreon.com/spacenuts. We thank you for your subscriptions. Very, very happy that you enjoy the program that much that you want to subscribe. Of course, the advantage of subscribing via Patreon is you get a commercial-free version of Space Nuts. I know some places get that at the moment anyway, but that's going to change in time. But if you sign up for Patreon, it is commercial free. You get the episode seamlessly from start to finish. We are also on YouTube if you want to catch up with some episodes there. All 155 episodes are on our YouTube space. I was going to say channel, but it's not really a channel, except it probably is. I don't know. I leave all that up to our producer, Hugh. Now, Fred, a question from David in Loserville, otherwise known as Queensland. I could probably eat my words. For those who don't understand what I'm talking about, every year the states of New South Wales and Queensland play off in a best-of-3 rugby league football series called the State of Origin. The players play for the state that they were born in or played junior football in. So there's a lot of feeling that goes into these games. In fact, it's probably the best series of the year in any form of football. And I know that's probably going to start some arguments, but that's just how I feel about it. New South Wales currently the champions for the first time in 3 million years. So they're defending their crown against Queensland, and they play tonight our time in Queensland, and we never win there. So I don't know why I'm talking it up, but there it is. So I'm giving David a bit of a hard time, and the best news of all is he can't answer me, not straight away. Anyway, David says, "G'day, gents, love the show," or he did.
Well, he might stop loving it now.
Which I've only recently discovered. Well, he's going to undiscover us, and have been listening to all the back episodes. During your latest one, May 31st, you talk about how water may have been deposited on Earth via comets. This jogged a question in the memory after listening to your Cassini-Saturn episode. Could Earth have had rings like Saturn that rained ice crystals down from them and formed our oceans? Yes. Well, very interesting question, David. What do you think, Fred?
Yeah, I think it's a great question. And I think the answer is it's entirely possible that there was a period in the Earth's history where we had rings. Because rings are not that uncommon. I mean, we always think of Saturn and the marvelous ring system of the planet Saturn, but all the gas giant planets have rings. Some of them are pretty anemic. In fact, all of them are fairly anemic compared with Saturn's. But also some of the smaller bodies in the solar system. There's a couple of really quite distant asteroids. They're called centaurs. They're icy asteroids that are between the orbit of Saturn and Uranus, if I remember rightly. And they too have rings. Not that we've seen them. We've seen them. We've discovered them by that process which we call occultations, where the shadow of a star passes across the Earth's surface. The shadow of the asteroid cast in the light of a star passes across the Earth's surface, and you can observe it from many different points, and you can discover the dimensions of the asteroid. But also, if you're lucky, you'll discover rings around it, and that's how these discoveries have been made. So rings are relatively common, and we think that they form, and certainly in the case of Saturn, the belief is that they have formed by either a comet colliding with one of the icy moons out there, or an icy a pair of icy moons colliding. The only issue with this idea that the Earth might have had ice rings around it is where it is, because the Earth is in the inner solar system, where it's receiving much more of the sun's radiation. Now, the sun's radiation has changed over the 4.6 billion year history of the solar system. So and we do know that the Earth went through a phase that we call the snowball Earth phase, when it was basically just frozen. And it may well be that at that time you could have had rings of ice around the Earth, which may, as is happening on Saturn, as we now know, they may have eventually drained down onto the Earth's surface and perhaps helped to form the oceans. But the bottom line is that they likely came originally from something like comets coming in and colliding nearby and perhaps forming rings around the Earth. It may just be an extra step in the process of ocean formation. But it's a good suggestion. It's certainly not beyond the realms of possibility that might have happened. It's very hard to know how we would discover.
Unlike Queensland losing the state of origin, which is certainly just an,
So just a word to David in Queensland. David, I'm a completely innocent bystander in this because as an outsider, I've never really understood the state of origin, but it does seem to be something that people here get very excited about. Most notably, my colleague sitting over there in Dubbo, Panning, which is actually a lot closer to Queensland than where I am, I have to say.
Yes, it is, but that doesn't mean anything. I did live in Queensland for a couple of years. Early in my radio career, worked for a station up there in Mackay, and I think we were there for 2 years, and I think in all that time, New South Wales won one game. And it was really hard to live there.
I bet it was.
Very hard to live there during those few months. But, we're all friends outside of the football.
Of course, that's right.
One of my very best mates is from Queensland. We met them when we moved to Mackay, and we're still great friends, and we still see each other every couple of years. But I appreciate the question, David. Well asked. And, yes, the answer to your question is possibly so. Now, it also leads me to something we're going to talk about in our next episode, Fred, which we did discuss briefly last week, and that was the question of heavy water, because they've come across potential new evidence that Earth's water may have come from asteroids, and it's water as we know it, obviously, but it could have been heavy water because there are different kinds of water out there. And I asked the question whether or not we could actually drink heavy water, or would life survive with heavy water rather than ordinary water or normal water or standard water, whatever you want to call it. So we'll get into that next week at length, because I did suggest that it was something we should investigate. One quick question that popped into my mind while we were talking about David's question. You talked about the shadows of asteroids passing over the Earth. I mean, we sometimes do see shadows on the Earth because of eclipses, but do we have regular shadows passing over us from great distances that go virtually unnoticed to the naked eye?
Yes, because, starlight is falling on the Earth from all directions, and the asteroid belt has got lots of objects in it. So there are indeed these phenomena. What usually happens if there's an interesting object likely to pass in front of a star, this is followed up assiduously by the astronomical community, because you can learn a lot from this process. So when there is one of these occultations forecasts, and there's software now that sort of generates predictions as to what's going to happen, then quite often there is a mustering of telescopes. It was the way that we discovered that Pluto has an atmosphere, Andrew, by observing Pluto passing in front of a distant star. This is quite a long time ago. It's more than 10 years ago, when the light of the star was seen to dim only gradually rather than switching off suddenly, as you would expect when an object with no atmosphere passes in front of it. So yes, it's happening all the time.
Yeah. We just don't notice it so much. You've got to know what you're looking for.
Yeah.
Very good. All right. That's just about it for this week. Fred, thank you so much.
Oh, it's a pleasure. Always good to talk.
And we will catch you next time. Astronomer Fred Watson, he's also a professor and a real nice guy. He'll be back next week on another edition of Space Nuts, as will I. Until then, take care, and we'll catch you again real soon.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.